designed experiment. All right, a designed experiment is something that allows us to be able to show cause and effect. And in essence, when you think about a designed experiment, you're thinking about intentionally changing the variables, doing something to change the variables. We're going to come back. I'm going to put this back up on the screen in just a minute, so don't worry about writing too much of it down because I'll give you an opportunity in a second. Whereas an observational study, if you think about the name right there, an observational study is really just observing. Okay, so you've got a designed experiment where you're intentionally changing something, and you have an observational study where you're just observing something. So having said that, I'd like for you to take those two examples that I gave you on the paper, all right? And I want you to determine, based on that information right there, which one of these is a designed experiment, which one is an observational study, and tell me why. So write it down on your papers. Don't write on my paper. Take just a second. Reading over the paper that I gave you, determine designed experiment, observational study, which one's which, and be able to explain why you came to that conclusion. All right, you done? Got them read? Yes or no? Shake your heads, yes or no. All right. Okay. So again, I gave you a piece of paper. You can start filling that information in now. That other handout that I gave you should help you be sure that you copy down and write down the information about both a designed experiment and an observational study. So when we think again about a designed experiment, we're going to assign groups, and then we are going to, so take those and pass them out. So we're going to assign groups, and then we're going to intentionally change variables within that group. And then we'll record the results. So when we think about a designed experiment, it becomes the way for us to be able to identify cause and effect. It's the only way we can identify cause and effect. So one thing causes another, okay? Whereas observational studies, you're just observing the behavior without influencing an outcome. So because of that, we are only allowed to say there can be an association between two variables, but we can't say in an observational study, we cannot say that one thing caused the other. Okay, so in an observational study, all we can say is, well, we think there's an association, but because we haven't done the experiment, we can't say one thing causes the other. Okay. Generally, when you think about an observational study, you might do an observational study to kind of determine whether there's an association, and then you would be able to go on and try to come up with some sort of experiment on that, based on that idea, based on that hypothesis, maybe that there is an association. Okay, so it does have a role. When we are looking at observational studies, we can look at observational studies because it might be unethical to conduct an experiment. All right, so look back at the two examples that I gave you. All right, and of those two examples, which one is which? What's the first one? The first example there, what was it considered? An observational study or an experiment?
Observational.
Why?
They didn't change anything,
They didn't change anything, they
they just observed.
just observed, right? Okay, and then the second one, what did they do? Do what? Yes, they divided them into groups and then changed the amount of radiation or radio frequencies, right, that they were exposed to. Okay, so you can see the difference between the two, right? Can you see why the experiment was conducted on rats and probably not humans? It would be unethical, right? It would be unethical to do something like that to cause harm to humans, right? Okay, so you can see the reason why we would do an observational study and then figure out how to do the designed experiment in an ethical way. Okay, so there's a paper that I handed out on the back if you want to grab it. So if we think about then our studies here, we've got in both studies that we're interested in, we've got two new variables that we kind of want to explain here. So when we do research, which is kind of the idea, we're trying to determine how varying some amount of that explanatory variable can affect the response variable. And that's the idea behind that. So for an explanatory variable, we think about an explanatory variable as being that treatment variable. What's explaining the response, okay? In mathematical terms, you can think of the explanatory variable as being the independent or X variable, if we want to look at it that way, all right? And therefore, the response variable, that's the outcome variable. All right, so the explanatory is our treatment variable. The response is the outcome variable. Mathematically, the response would end up being the dependent variable or the Y variable, if we want to look at it that way. So from the two problems that we had before, who can tell me what they think the explanatory variable would be from our previous examples? The phone radiation, okay, maybe the phone usage, all right. What would be the outcome variable? Right, you're trying to measure brain tumors, okay? So again, the explanatory variable becomes the treatment variable. Make sure you got that word written down, treatment variable for explanatory. And the response variable, again, is the outcome. Sometimes, and I do this in math, in word problems in math also, sometimes if you're having a hard time recognizing what the explanatory variable is, sometimes it's easier to identify what the outcome is. If you identify what the outcome is and then work backwards, okay, well, what's causing this outcome? What are they looking at to give me this outcome? That gives you the explanatory variable. So sometimes you can go backwards in that way. All right, questions on these two concepts right here. So let's look at some more information about this. Okay, so we've got our two variables, or our two variables that we're looking at that we're helping to answer questions about. But there's some other ideas that can go into, there's other variables or factors, I guess, that can go into a study. And those variables are considered confounding and lurking variables. So let's look at this example here. It says researchers wanted to determine the long-term benefits of the influenza vaccine on seniors aged 65 years and older. They looked at the records of over 36,000 seniors for 10 years, divided them up into two groups. Group one was those seniors who got the flu shot. Group two were those who did not. After observing the seniors for 10 years, it was determined that those who got the flu shot are 27% less likely to be hospitalized for pneumonia and 48% less likely to die from a pneumonia. Okay, so just based on that information right there, if you saw those numbers and you saw that scenario, would you be able to say that you would recommend that all seniors go out and get a flu shot? Why? No? Why?
I don't know, the like percentage rates, they seem a little low to me. I would want to choose getting the flu shot if it was a little bit higher.
Okay, so you're not really convinced by the percentages that were there. All right, fair enough. What else? Just based on the numbers that you see up there, okay? Just based on the numbers, if there's a slightly better chance, then maybe somebody would be able to say, okay, well, that's better than nothing, right? If you're 27% less likely and 48% less likely, right, then that's better than nothing. Sometimes some people would maybe be able to argue that. But the point of this is talking about, well, are there any other factors that could have been behind the scene, if you will, and not taken into account that affected the outcome of the study? So what we have here is what we call lurking factors or lurking variables. A lurking variable is something that is not considered in the study, right? So you don't consider it in the study, but it affects the value of that response outcome. Okay, so you don't take it into account in the study, but it does have an impact on the study. That's what's considered a lurking variable. Kind of, again, the name, it means it's lurking in the background, right? So if we're thinking about this study, some examples of a lurking variable might be age. Now, the study says that they took seniors 65 years and older. There's a big difference between a 65-year-old and an 85-year-old, right? Okay, so that could be considered a lurking variable. Health status. The health status could be considered a lurking variable that we might have. The mobility of the senior, maybe they, in addition to their health status, maybe they are out and about and around a bunch of other people as opposed to others who maybe aren't. So all of those things are what we consider lurking variables that you don't take into consideration, or you can't even take into consideration sometimes in the study, but yet it still impacts the outcome. Okay. Now, the other variable that we have is what's called a confounding variable. So with a confounding variable, you do take it into consideration. You kind of can try to mitigate it, so to speak. All right. You kind of in advance, you're thinking, well, these might be some factors that I'm looking at. Okay. But what happens is, even though you may have taken that into consideration, that confounding variable can make your outcome to where you can't really distinguish whether or not that variable played an impact or not. Okay, so it was considered, but you can't distinguish from the explanatory variable in the study. Is for a confounding variable. Okay, the handout that I gave is in the back of the room if you want to grab it. Okay. All right. Now, an example of a confounding variable. So if I were, there was a study that I read in the textbook, said that a teacher wanted to know whether or not online assignments versus traditional textbook assignments were better. She's trying to determine through the study. And so she had two classes that she wanted to compare. And in that study, she had one class that was in the morning and she had one class in the afternoon. Now, the confounding variable here, okay, was the time of day for the study, right? So the early morning, just like y'all, right? Maybe 9 o'clock class, something like that, compared to maybe a 1 or a 2 o'clock class. All right, what do you think the differences in those two classes would be? Or what do you think the differences would be?
I think morning would prefer online just because they don't have to get out of bed. Second class would prefer like textbook work.
Well, okay, I see what you're saying, but she was talking about, I know what you're talking about. So let me go back and rephrase it. She wasn't talking about you being an online student. She was talking about, in essence, what we have in our class, the online homework, right? Compare like digital online homework, we'll just call it that, versus just getting a textbook and working straight out of the textbook. So you still were face to face. All right, so what do you think the differences would be then between a morning, maybe in an afternoon class?
One could be more motivated to do it.
One could be more motivated. I would maybe even say one is maybe more focused. So if you think about the morning time, all right, I know it's 8 o'clock in the morning, but you know, you kind of are still getting up. You maybe are a little bit more focused. You may not be quite awake, but you're still here, right? And then it just kind of keeps getting better until about lunchtime, right? And then after that, in the afternoon, students tend to be a little less focused. They're a little tired. It's been a long day so far, all right? So the time of the class period ended up being a confounding variable so that the results that she found, you aren't able to tell whether or not students did better or worse because you had this morning time versus afternoon time. Do you see what I'm talking about for that? Okay, on that confounding variable. All right. Now, in addition to our variable types, we have 3 different types of observational studies. The first type of observational study is what we call a cross-sectional study. So generally with a cross-sectional study, you just collect information about some individuals at a given point or maybe over a short period of time. But you're just kind of collecting this information. Okay, that's a cross-sectional study. A case-controlled study generally has us, it's considered retrospective. And so in a case-controlled study here, we're going to look back at existing records, something that was already maybe compiled or data was already taken on it, something like that, but you're just going to look backwards to be able to do a study on it. And you can see for our case-controlled study, they're also thinking about individuals who have certain characteristics and are matched with those that do not. So we're looking back. And then finally, the third type is what we call a cohort. So in a cohort study, they typically will take a group or individuals that maybe have a common characteristic. That becomes the cohort, and then they follow the cohort over a longer period of time. So for example, here at MCC, it might be interesting for, because we have a research department, and they might take the nursing students that are here, so that would be the ones that are in the RN program, okay? That would be the cohort, and then they would follow them through the program as well as potentially maybe a little bit further to see how well they do after they graduate. So those are the 3 types. Case control, where it's just individuals and from a specific point in time or maybe over a short period of time. Don't kind of fall for too much of the short period of time part. Case control, like I said, is typically retrospective, looking backwards in time. And then a cohort is a group of individuals you've identified that you follow over a longer period of time. Are there questions over that? Great. All right, so what I want y'all to do is I want you to work in groups of 2, 3, or 4, all right, people that are around you. And I would like for you to answer the rest of the questions on that paper below that black line. I think there's about 4 questions front and back that you need to answer. And we'll go ahead and go over the answers in a few minutes. Okay, you got about 10 minutes to answer those questions. And I'd like for you to be sure that you're working with other people. Okay, so for the first one, a poll is conducted in which 500 people are asked whom they plan to vote for in the upcoming election. What do you say?
Observational.
It's observational and what type? Cross-sectional. You're at a specific point in time. Okay? You're at a specific point in time moving forward. All right, the next one, breathing techniques for yoga. Okay, what is that? It's an experiment, and why? Pulse rate. Right, they assigned groups and then they intentionally changed things in the groups, right? Okay, and then they evaluated something at the end. So they intentionally changed the variable from within. Okay, how about the next one? Hypertension. What about that one?
Observational.
Observational, and what type? Cohort, that's right. Okay, they're following the adolescents over several years. Finally, the last one. Okay, why is that an observational study?
That was different groups and they didn't change variables.
Right, they did not intentionally alter the groups. Okay, what type of a observational study was it? A cohort, very good. What's the response variable here? Weight gain, very good. The response variable, what they're trying to measure here is weight gain. Now, is that quantitative or qualitative? Quantitative, very good. All right. What's the explanatory variable? Okay, so their living status. Forgot how somebody said it yesterday. It was exact, huh? Not a marital status, but their living arrangement or whatever, right? Okay. Is that qualitative or quantitative? Qualitative, because it's just categorical, right? Okay. What would some lurking variables be here in this scenario? Eating habits, right? That's a good one. Maybe you're eating out more. What else? Physical activity. Okay, good. What else?
Predisposition to some kind of disorder, weight gain.
Okay, sure. Genetics. Yeah. Having children, maybe that could affect it also, right? Okay. Can you conclude that getting married or living with somebody causes weight gain? No, you can't conclude that, but why?
Because it's an observational study rather than an experiment.
It's an observational study and not an experiment. So what we can say is that there is an association between cohabitation, married, and gaining weight. The association could be there, which is what we're saying here, I think, from the study, just not that because you're living with somebody, it's going to cause you to gain weight. Okay? All right, so the association part. Very good. All right, you can move back to your seats if you had moved originally. We will pick up and we'll talk about the next part of this. So now that we kind of understand the types of studies that we have, both an experimental design as well as an observational study, let's go a little bit deeper into an experiment, the design specifically of an experiment. So if we need to kind of have some terminology again as we move forward here. So when we think about the design of our experiment, remember an observational study only allows us to be able to say association. So we need to have that experiment to be able to show cause and effect. So for an experimental unit or a subject, we would say that that is the person or the object or something like that, which the treatment is applied. The explanatory variable gets applied to that, okay? All right, so that's our experimental unit, that's our subject. We have a control group. The control group is what's going to be used to serve as that baseline treatment. So we have a baseline that we can then compare the other treatments to. When you have a control group, that's what the idea is. All right. Has anybody ever heard of a placebo effect? Can you tell me about it?
It's like when they plant the idea that something's going to cause this.
Yeah.
You like mentally think it's possible and then you give yourself like.
You're on the right track. Y'all want to help her out with that? She's right. Want to add to it?
They give you a pill saying it's gonna do this to you, but it's just like a sugar pill or something. And you actually have the effect from that pill.
That's right. So it's like a mental thing, right?
Yes.
They're giving you pretend, right? They're giving you fake placebo, they call it, medication that would be exactly like what you're thinking it is, what it's supposed to be in the experiment. And yet you could have the same effect as the people who did have the medication. They said, I think it was in the reading, that this is useful, that this is something that's used in like anxiety, depression, those types of medication and studies. It can be shown that the placebo effect does in fact cause positive results. Somebody asked me yesterday if that was ethical, which I believe it is, right? Because you wouldn't want to do something that was intentionally harming somebody else. So you would not use a placebo effect, let's say if you were studying cancer, right? Medication. So, because I would not ever want to withhold the cancer medication from you and give you pretend medication. That would be the unethical part of it, okay? So placebo is this kind of pretend medicine, let's say. And then, let me back up for just a second. Does anybody know about a single blind or a double blind experiment? You ever heard of those before? Single blind and double blind? No? Okay, so in a single blind experiment, when you hear about in a single blind experiment, what they're doing is the people that are receiving the treatment, they don't know what treatment they're getting. So they don't know whether they're getting that placebo or not, okay? The experimental unit or subjects do not know which treatment he or she is receiving. That's a single blind, it's only on one end. So a double blind experiment is where neither the administrator of the experiment, right, the person giving the experiment, they don't know what you're getting, and the subjects don't know what you're getting. All right, so on both ends of that, they don't know. All right, why do you think that that would be something that would be, because a lot of experiments that are designed well are done in this particular way. Why do you think that that's a good thing to have happen? For both the administrator and the receivers to not know what they're getting. I think it can cause bias, right? You're trying to remove any type of, questioning about your study. And so if you there's all sorts of other things that can lead to bias within the study. So this is just one way for you to be able to remove that aspect where if I don't know whether or not you're receiving the placebo or not, okay, then I can't be accused of having some sort of bias in one group or the other, okay? So you have a single blind experiment where it's only the receivers who don't know. And you have a double blind experiment where both the giver and the receiver do not know about what they're receiving. Okay, so those are some terms that we're going to be using. And let's look at just kind of the general characteristics of our experiment and see if we can identify some of these things. Now, if you don't get all of this written down right now, you just make sure that you write down that heading, single blind, double blind, and those things, and you can always go back and refer to this from the textbook, okay? All right, so what I have here is an experiment, pretty long one, and we're going to identify some characteristics out of it. It says researchers conducted a double-blind, placebo-controlled, repeated measures experiment to compare the effectiveness of a commercial caffeinated carbohydrate electrolyte sports drink with a commercial non-caffeinated carbohydrate electric sports drink and a flavored water placebo. 16 highly trained cyclists each completed 3 trials of prolonged cycling in a warm environment. 1 while receiving the placebo, 1 while receiving the non-caffeinated sports drink, and 1 while receiving the caffeinated sports drink. For a given trial, 1 beverage treatment was administered throughout a 2-hour variable intensity cycling bout, followed by a 15-minute performance ride. Total work in kilojoules performed during the final 15 minutes was used to measure the performance. The beverage order for the individual subjects was randomly assigned. A period of at least 5 days separated the trials, took place all about the same time, blah, blah, blah. The researchers found that cycling performance as assessed by the total work completed during the performance ride was 23% greater for the caffeinated drink than for the placebo, and 15% greater for the caffeinated drink than the non-caffeinated. Cycling performance for non-caffeinated and the placebo were not significantly different. The researchers concluded that the caffeinated sports drink substantially enhanced physical performance during these prolonged exercise compared with the non-caffeinated one. Okay, y'all ever heard that before? I think it was fairly recently that I started seeing it, that they were saying a cup of coffee before you go exercise is not a bad thing anymore. You used to think that maybe it would be bad for your heart or something like that. Now they're saying that it's not. That's kind of the idea behind this study, I think. So what does it mean, since it told us at the beginning up there that this was a double-blind, placebo-controlled experiment? What does it mean for it to be placebo-controlled? Remember what a control is. Okay, what was a control? We said it in the previous screen. Okay, and so what are they using then as the baseline treatment here? The placebo. Okay, so think about that for a second. You're going to administer the placebo, the caffeinated and the uncaffeinated drinks. You run the cyclists through using a placebo to get a baseline. Then you can use that baseline to be able to see how well the caffeinated and the non-caffeinated are affecting their work performance. Because I would assume every work performance for each of the individuals would be different, right? So you got to have a baseline to start on, and that's what the placebo control means. What does it mean for this to be a double-blind experiment?
Cyclists didn't know which one they were getting, and the person handing it to them didn't know what they were getting.
Right, neither the giver nor the receiver knew which one of the drinks they were given at a given time. So each cyclist received all 3 drinks, okay? But when they gave them the drink, neither one knew which drink that was, okay? Because it might influence you, right? Maybe it's the placebo effect. Maybe I'm gonna work harder on it or something like that, right? So they needed to not know what that was. What's the population of this study? Remember, that was part of the process at the very beginning, where you wanted to make sure you identified the population to which you were wanting to infer this information.
Athlete trained cyclists.
That's what I think it is, but does anybody think it's anything else? Anybody got another thing they want to offer up? Destiny, you want to go for another one?
What did you say?
You said highly trained cyclists, right, Noah?
I would think maybe cardio-based athletes.
What did you say?
Maybe like athletes in general that do cardio.
Right? Yeah, so high intent, something like prolonged exercise athletes or something like that, right? Okay, so that's correct. The population are athletes who perform prolonged exercise periods. What is our sample here? 16 cyclists, right? I would probably argue that if this was my design, my experiment, I would probably say, okay, well, if I want my population to be the people who do prolonged exercises, Maybe I want to add in there some people who are marathon runners or triathletes, or maybe kind of have those in there and not so specific, because it seems somewhat specific to me to say, okay, well, let's just look at cyclists. Now, I don't know, maybe that's the easier, maybe it's easier to measure performance output. So I'm not the experimenter, but that's what I thought. The official answer is exactly what you said, Destiny, that it's the athletes who perform prolonged exercise periods, okay? What are the treatments that we have here?
Sports drink, non-caffeinated, placebo.
Caffeinated, non-caffeinated, and placebo, right? So a caffeinated sports drink, non-caffeinated sports drink, and then the placebo water. What's the response variable? What are they using to make their conclusion?
Total work completed
The total work completed measured in
the last 15 minutes.
kilojoules. Kilojoules, right? So is that a qualitative or a quantitative variable? Quantitative, very good. Okay. Notice that the explanatory variable, right, which is our sports drinks, what type of variable would that explanatory variable be? Qualitative or quantitative? Qualitative? What are the treatments? You already named them for me. All right, so it was the non-caffeinated, caffeinated, and the placebo, right? So are those categories that I could group? So it would end up being kind of qualitative in nature. All I want to point out to you is that when we're looking at these experiments, everything doesn't have to be a single variable. Notice the explanatory variable is qualitative, and yet what they're measuring the result in is quantitative. Okay, so you can have a mixture of the two types of variables in your design experiment. So they don't have to be the same one. Okay. Now, notice also in here, it says, I think it's in the middle of, it's in the middle of the second paragraph. It says the beverage order for the individual subjects was randomly assigned. So remember how we said that it's double blind, nobody knows who's getting what. The other thing that they do with a randomization in generally to try to keep it, I guess, fair to lessen the bias is to for each athlete, you just randomly pick which one they're getting, right? So that randomization typically helps us to kind of address any type of lurking or confounding variables that we might have. In essence, it's going to help average some things out, and we'll see what that looks like in just a second. Okay, so in this particular example right here, we have what we call a completely randomized design. And so what they're doing, it says researchers enrolled 247 women between the ages of 70 and 93 in a study. They were randomly assigned into 3 groups. Group 1 attended a computer class 3 times a week for 90 minutes. Group 2 enrolled in an exercise program 3 times a week for 90 minutes. And group 3 were told to stick to their normal routines. After 6 months, the women were issued a survey that results in an age satisfaction score. They found group 2 had a significantly higher age satisfaction than the other 2. This is an example of what we call a completely randomized design. So how many groups were there? How many treatment groups were there? There was 3 of them, right? So what they do in a completely randomized design is they would take their treatment groups, in this case there's 3 of them. They had 247 women, and they divided 247 by 3. That's going to give you 82, 82, and 83, because it's not an even number, right? Okay. Now, the completely randomized part of that is of those 247 women, they randomly assign them to one of the 3 groups, okay? And then they perform the treatment all women in that single group perform the treatment of either computers, exercise, or nothing. Okay, so that's an example of a completely randomized group. You take this group that's together, divide it up into your treatments, perform the treatments or the experiment in those groups, then bring them all back together that they did at the end and gave them a survey and then analyzed the survey from there. Now, what happens here is by completely randomizing it like this, you do that average, it averages out any type of lurking variables that could be happening. So for example, if maybe I had some women who, I don't know, didn't know a thing about computers, right? Technology. Maybe they have poor eyesight. Maybe they don't like to sit for very long. Maybe you have women who are, I'm sure they would probably make sure that you're fit enough to exercise, but maybe they're not very good at exercising. Maybe they have an underlying condition to consider, right? All of those types of lurking variables that can affect the outcome get neutralized by randomly assigning them to these groups. Because if you randomly assign them to each of the three groups, you're likely to have, let's say in the exercise group, some women who aren't going to be good in that group, right? Something like that. Okay, well, in the long run, the average of the people in that group are still going to give you a good understanding of that type of that outcome. So in randomizing it, you're hoping that it averages out the results from those three groups, from each of the groups. Does that make sense? Yeah? Okay, so that's what we call a completely randomized design. This next design, this is called a matched pairs design. In a matched pairs design, what we have here are two levels of treatment. Okay, that's it. You only get two because it's a pair, right? Matched pair design. Okay, you only get two treatment levels. So this example says xylitol was proven effective in preventing dental caries or cavities when included in food or gum. A total of 75 Peruvian children were given milk with and without xylitol and asked to evaluate the taste of each. Researchers measured the children's ratings of the two types of milk. So you can see you only had two treatment groups, right? That's kind of the idea behind a matched pairs design in this particular case. Okay. Any questions on these experiment designs? No, so far? All right, so what I have two more experiments that I want y'all to look over and answer some questions about. And I'll give you about 10 or 15 minutes to get this finished. And then we'll come back together and go over the answers together. So make sure that you're working with other people, please. And then we'll go over the answers. Okay, so the green tea one. In part A, it's an observational study. Why is it an observational study? Because they didn't do anything to influence either of the two groups, right? Okay, now what is the explanatory variable? Right, whether or not they drank green tea, and is that qualitative or quantitative? Qualitative, right? Because how would you respond to that answer? Yes or no, right? So it's qualitative. What do you suppose some lurking variables might be in this that would affect your cholesterol level?
What type of green tea?
Genetics, the type of green tea, is that what you said, Asia? Yes, probably if it was an observational study, they can't control that, can they? Okay. What else? Age, maybe, right? Genetics, like Noah was saying to me, genetics is a pretty easy one to kind of see. You can't control genetics, can you? Yeah, that's just there. Lifestyles, you can't control that so much as well. So now they change it in part C to an experiment. What type of experimental design is this? Is it a matched pairs, completely randomized?
Random, it sounds like it's random.
It's random, but we're gonna go one step further and we're gonna call it completely randomized, okay? In this particular case, it would be completely randomized. You've got the 3 groups, so it can't be matched pairs. Matched pairs, you can only have 2 groups, period. You got 3 groups. They're gonna take those 120 people, they're gonna shake them up and they're gonna randomly distribute them to the 3 groups. They're gonna assign them to the 3 treatment groups. I'm kind of skipping forward here, but that allows for a correction, if you will, to the lurking variable of the genetics problem. Because you're gonna hope that on average, you get people who are genetically predisposed to high cholesterol in each of the 3 groups. Okay, I think we know what blinding is on this, but what is the factor, skipping to the next one, what is the factor that is manipulated here in the experiment? How did they, the amount of tea, right? You had a placebo, you had a 1 cup, or you had a 2 cup. So therefore, what type of variable would that be? It's qualitative because it's a category, really. It doesn't really have a mathematical meaning, the 1, 0, 1, and 2. Okay, so it's just a category in essence. What factors, if you can't control the genetics and you're trying to control factors here, this is where we're thinking of confounding or trying to be able to control them just as they are. What are things you could control if you were designing this experiment? How? Through what? Diet, that's right. So you could control the diet, correct? What else could you control? What always goes along with diet?
Exercise.
Diet and exercise, right? Those are some things that you could control in this, right? Very good. Okay, then moving to the last one down there, the health and diet, priming for healthy food. What is the research objective here? Alerting shoppers of unhealthy snack changes if alerting them changes their shopping habits, right? Think about being bombarded at the beginning of this grocery store. They hand you a pamphlet. Are you gonna read it and adjust your grocery shopping or not? That's kind of what they're assuming here. Who are the subjects? The 42 overweight shoppers. Okay, why do you suppose blinding is not possible here? Because you just gave them the pamphlet, right? They already know. All right. What's the explanatory variable? What's the treatment variable? The pamphlet, whether or not you got the pamphlet. Okay. Oh, yeah, which pamphlet you got? I'm sorry, no, yes, whether you got the healthy one or the non-healthy one, I suppose. What's the response the response variable is the number of unhealthy snacks that they ended up purchasing. Is that quantitative or qualitative? Quantitative? Yeah? All right, very good.